11 notes. Solving polynomials using the rational root theorem. So we're going to apply this new theorem to help find solutions to solve and graph polynomials. So up to this point, we've given you a solution or a factor of a polynomial. We either used numbers, used static division, or we told you test to see if it was divisible by this binomial. But in this lesson, you're going to have to do everything on your own. And if you think about it, any polynomial, we'll come back to this in a minute. Any polynomial like number 1, 2x cubed minus 2x squared plus 5x plus 21. It's not like saying one of the factors is 35. Oh, 1, 5, 7, 35. That's easy. Those are all the answers. Just 4 factors. That's no problem. And in the past, we might have told you, hey, test and see if this is divisible by x plus 2 or x minus 3. And maybe one of those worked out. But in this case, we're saying find a factor of that. Well, hopefully you understand that there are an infinite number of possible solutions. And it could take forever to just say, hey, let's try 3, or 1/2, or negative 2/3. It could take forever that way. So the rational root theorem is a way to cut down on that time and kind of give you a method to the madness. So this is just saying if we have a polynomial that has integer coefficients, then every rational, real and complex, solution has the following form. P over Q. P is the factor of the constant term, and Q is the factor of that leading coefficient right there. So let's dive into this and see how it works. Find all possible real roots. So we identify P and Q. P over Q. 21 over 2. What are the possible factors of 21? 1, 3, 7, 21. 1 and 2. Now you can list these out any way you want. You can do all the P's divided by 1 and then all the P's divided by 2. Or you can divide each of the P's by 1 and then each of the P's by 2 as you go along. You're going to get the same list, just going to be in a different order. I personally am going to do all the whole numbers first. So 1 divided by 1. And we have to remember plus or minus in each of these. So 1 divided by 1. 3 divided by 1. 7 divided by 1. And 21 divided by 1. Those are my whole numbers. Well, we got to keep going. There's also plus or minus 1 divided by 2. And plus or minus 3 divided by 2. And plus or minus 7 divided by 2. And finally, plus or minus 21 divided by 2. Those are all my possible solutions. 2, 4, 6, 8, 10, 12, 14, 16 different numbers that we use the negative division on to find a factor of this polynomial. That's a lot. I'm also going to teach you a way to cut down on that number here. Let's do it again. P, Q. P over Q, 12 over 2. 1, 2, 3, 4, 6, 12. 1, 2. I'm going to do all my whole numbers first. So, plus or minus 1 divided by 1. Plus or minus 2 divided by 1. Plus or minus 3. Plus or minus 4. Plus or minus 6. And plus or minus 12. All divided by 1. Now I got to divide each of those by 2. Plus or minus 1 divided by 2. Now, plus or minus 2 divided by 2 is 1, which we already have. So we save time. So we go to 3 divided by 2. And then 4 divided by 2, we already have. And 6 divided by 2, we already have. And 12 divided by 2, we already have. So we're done. possible real roots. They're not all real roots of this polynomial, but any answers we get lie within those 16 possibilities. So, number 3. We're going to solve the polynomial. So let's see. Hey, this box tells us how to do that. Step 1, find all the possible zeros. That's our P. That's our Q. P over Q, 15 over 1, 1, 3, 5, 15, 1. So that tells me it's plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Now, even though that's only 2, 4, 6, 8 possibilities, I'm going to give you a preview here. There's actually 3 of those 8 are real roots. So 3 out of 8, that's pretty good odds. That's almost 50-50, which means if I just picked one, I'd have a pretty good chance of, with synthetic division, getting the right one. But still, I want to cut down my odds. So I'm going to use a graphing calculator. I'm going to add this little step in here to help me narrow down my possibilities. So what I've done here is I've taken my graphing calculator and I've entered in x cubed plus x squared minus 17x plus 15. And I hit graph. And here are my solutions. Now it looks like they hit right on the marks. 1, 2, 3, 4, 5. 1, 2, 3. So it looks like negative 5, 1, and 3. But I can use my table to confirm. Well, there's negative 5. Here's 1. And there's 3. Now I can check, because I also said possibly 5, but that's 80. And 15 is obviously going to be a big number, so that's not going to work. And if I went further back, I could check out negative 1. Nope. And negative 3. And negative 5. And then negative 5 worked. We found that. And negative 15, sorry, doesn't work. So I've kind of cheated and said, oh, I know the answers. It's negative 5, 1, and 3. And although the calculator is nice and helps us here, it doesn't mean that's all the possible answers. That just means those 3 are definitely roots or solutions. But what if, and I know we saw from looking at the graph, we only had the 1 root because it is cubic. And since it's cubic, it's only going to hit once for real. But still, we need to check how it looks. Sorry, let's think about a different problem. This one, like we saw, actually hits 3 times, so we know it is going to be only those solutions. But there are times that we may not have them all. And that's why we still have to do the work and confirm what all of our solutions are. So I'm going to do synthetic division. I can pick any one of those numbers. I'm going to pick 1. So I'm going to start here. 1, 1, negative 17, 15. Drop down, multiply, add. Multiply, add, multiply. There's my 0. Now notice in step 2 it says use synthetic division to get 3 numbers. 1, 2, 3, and a 0. Well, I have 1, 2, 3, and a 0. So now my next step is to either factor the square root property or the quadratic formula. And remember, the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to try factoring first, and I'm going to try to factor 1x squared plus 2x minus 15 equals 0. I'm going to use some these three are all solutions. Now, if you want, you can fast forward, and you don't have to take any more notes on this. You can fast forward until you see me go on to the next page. But I want to show you that if I tried the same thing with the 3 instead of the 1, I would have still gotten 1, 2, 3, and a 0. And if I would have done the same thing with -5, it would have also worked out, because those are all factors. Some of you may be joining me back, some of you may have watched through. But one more thing about that previous one, after showing you that all 3 weren't in synthetic division, let's say I would have tried -1, or -3, or +5. I would have not gotten a remainder of 0, which means it was not a factor. But using the calculator did help us save time. So in this case, graphs are useful. We just proved that. In this case, we're looking at a cubic function. Now notice, it's hard to tell here, but that's our x-axis and that's our y-axis. See where the numbers are? A little blurry. Well, here is our one time, our one solution. But since this is a cubic function, we know there are actually 3 solutions. There have to be. So if we only have one real solution, the other 2 must be complex. Over here, we have what looks like a parabola, but it's not a quadratic, it's a quartic function. Well, we can clearly see that we only have 2 real solutions, but we should have 4. Well, we do. We have 2 real solutions and 2 that are complex or imaginary. So don't let your eyes deceive you. If you only see 2 and it's a quartic function, there are 2 that we don't see because they're imaginary. Let's move on to example 4 here, solving the polynomial. Well, in this case, this one's not ready yet. We need to rewrite this in standard form. Now, we can do our P's and Q's. P, Q. 20 over 1. So 1, 2, 4, 5, 10, 20. Those are our possible solutions, or possible factors of 20. Possible factors of 1 or just 1. So all the possible roots of this polynomial are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. 2, 4, 6, 8, 10, 12. 12 possibilities. So we're going to use our handy dandy calculator to help us narrow this down. So I've entered it into the calculator right here. I'm going to hit graph. And that's all I've got. Now remember, this is a cubic function, so that just means it's going up here and somewhere up here curving over and going up towards positive infinity. We can't see it. We could change the window to see, but it looks like there's my one solution. Now what is that number? We don't know. It looks like it's -2, but it could always also be a decimal. It could be a fraction. In this case, we know it's not going to be, but in other problems, we never know when we have fractions if it's one of those, and will not show up in the table if it is a fraction, because these are all whole numbers. We could change it to find fractions, but we can't find every fraction. But it tells me right there, there's my number, my solution, -2. So that tells me what number I want to use. Out of these 12 possibilities, I want to use -2. Now, if I were to just start with 1, and then -1, and 2, and then -2, it would have been my 4th time through. It would have taken me 4 tries with synthetic division, but now I know to start with -2. Now I'm going to get it the first time. So there's my cubic. Remember, I need make a placeholder for my x squared because I don't have one up here. Here's my 6 for my linear, and then there's my 20. Drop down, multiply, add, multiply, add, multiply, add. I have my 1, 2, 3 numbers, 1, 2, 3, and a 0. So I'm ready to go. This is x squared minus 2x plus 10 equals 0. So I want to try to factor it. Well, if I try to factor with guess and check, there's no two numbers that multiply to give me 10 that add up to negative 2. Doesn't work. So this one does not factor, which means I either need to use the square root property, which won't work on this one. I got too much information, so I'm going to have to go with my quad. So that is x equals the opposite of b, which is negative, plus or minus the square root of b squared minus 4ac all over 2a. Now, after I do this, I will get x equals 2 plus or minus the square root of negative 36 over 2. Well, square root of 36 is 6. And square root of negative 1 is I all over 2. I can simplify. I get x equals 1 plus or minus 3i. And those are two of my possible solutions. But we cannot forget this bad boy up here. And if you remember what we said up here, top, when we have a cubic function and there's our one solution, let's say negative 2, then we have two complex answers, which we have right here. So here's my one real answer, and here are my two plus or minus complex or imaginary. So there you have it. One real answer, two complex. And let's move on to our last problem. X to the fourth, x cubed, 7x squared, 9x, negative 18. B, 2. 18, 1. 1, 2, 3, 6, 9, 18, and 1. Which gives me plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. 2, 4, 6, 8, 10, 12 possible answers. So at the same time, I would put this in the calculator and find out some of my possible answers. And that would be 1 and negative 2. So I'm going to do my synthetic division right here with 1. My fourth root, my third root, exponent of 4, exponent of 3, exponent of 2, exponent of 1, and my constant, negative 18. Drop down, multiply, add, multiply, add, multiply, add, multiply. Now, remember, we want to get 3 numbers and a 0. We have 4 numbers here. I could do synthetic division at this point, and then find my answer. And like I said, I know there's going to be 1 and negative 2. So we're going to do 2 things here. I'm going to do the synthetic division, and then we're going to go back and talk about what else we could have done. So I'll put my negative 2 here, drop down, negative 2, add, multiply, add, multiply, add. There's my 0. I have my 1, 2, 3 numbers. And so this simplifies to x squared plus 9 equals 0. can use the square root property. X squared equals -9. So x equals the square root of -9, which is plus or minus 3i. Now, do I have my 4 roots? 1, 2, 3, 4. I do. Those are my 4 solutions. Solutions are 1, -2, plus 3 or minus 3i. So, if I was going to do this, I would not do that. Here's my 1, here's my -2. I could look in my graphing calculator and see what the y-intercept is, which is going to be down here at -18. So I know this is going to do something like that. That's a horrible function drawn, but you get the general idea. And that's what it would be like on the calculator, only better. But, like I said, I could have stopped when I had my numbers of 1, 2, 9, and 18. Because that would be x cubed plus 2x squared plus 9x plus 18. And if I look at factoring by grouping, remember, factoring is a possibility. I can take out x squared and get x plus 2. Pull out 9 and get x plus 2. And then what I get is x squared plus 9, x plus 2. Set these both equal to 0. And here's where I would have got my plus or minus 3i, and here's where I would have got my -2. So whatever you want to do, your possibilities are, I could have done standard division one more step, or if I see it as factorable, I could have done that right there. It's going to be pretty much close to the same amount of work, but it's your choice.